Welcome back, everybody. Eadsy Astronomy, Jay here. I want to just share something with you I've been working on. I'm going through a lot of my observations. You can kind of see them. They're all scattered over here. And putting together, I haven't really posted on my old blog any of my observations from June forward. So I'm in the process of catching up to those, taking images, using the camera to get those images done, getting them in, and doing my observation and recording it. I like to make a post. Some people like to read it. That's why I do it. They could be at work or somewhere and they can read short little segments instead of watching the video. Those who want to watch the video and listen to me, that's fine. That way I give you the choice of which way you'd like to get the information. Doesn't matter to me. I do think video is the way of enhancing the regular post in a blog or anything like that. But anyway, gonna ask you a question. Do you love spaghetti? We had spaghetti tonight. I can't have tomato sauce for a health condition I have, but so I do pasta with some vegetables, a little bit of because I'm lactose intolerant, on top of about 3 other things, some dairy-free Parmesan with mixed vegetables cooked up, put into the pasta with just a little bit of a homemade like pesto that's gluten-free and dairy-free. So yeah, there you go. I'm a celiac. I have to be lactose-free. Also have kidney disease, so I have to really watch what I eat. I've put on about 20 pounds and now working to get that back off over the last couple months. Just been all over the place lately. So anyway, things are going good that way. But back here, my granddaughter asked tonight, because they live with us, if she could have spaghetti. She wanted it last night. My wife made cranberry pork chops, which were delicious, but to appease the granddaughter, who is captured Yaya, which is my wife, her grandmother, and Papa's hearts wrapped around her finger, so to speak. Of course, she gets spaghetti tonight. So do you love spaghetti? Then this episode is for you. We're going to go through Simeis 147. It's called the Spaghetti Nebula. Visually, it doesn't look like spaghetti. I'm going to say that at the end, but I'm just going to tell you up front. But kind of does, and I'll show you an image really quick here in a second of some people thinking that it does. We'll kind of go through the history of it. We're going to talk about when I observed it before. Right here on my blog, I'll pop over. On January 17th, 2017, I actually went and observed this in the 17 and a half. This is an image. You can see that's why they call it the Spaghetti Nebula. They say all the filaments kind of look like a bowl of spaghetti mixed up. So I can kind of see that in there. Maybe you can. So if you're an imager, this is a great object to go after an image. And it's going to take a lot of exposure. It's going to take a lot of processing time. But I think the end product can be well worth it if you're into imaging. Visually, it's a challenge. It's a really good challenge. It will test your observing skills. I need to acknowledge, I acknowledge on the post on Patreon at Eadsy Astronomy. I acknowledge it here on my blog. I have to give all credit to Rich Jekyll and Jim Shields from Adventures in Deep Space. I used their information, modified a little bit for me, but I really used their information a lot in order to find the brighter elements on this object. And I'll just point out here, and we'll show you on the Patreon too, the brighter objects that Jim shares. Region A is right here, right through here. Region B is right through here. See, I see it's that little square, rectangle, whatever you want to call it, door. It's this area right in here, that region B. Region C is this area right up in here, and then this is region D. Those are the four areas that you can see filaments, some knots, some brighter portions of this supernova remnant if you go there. So let's jump in. I've put a link to the blog if you want to go back. I actually still have the original sketches here that are on the blog. This was region A. Just kind of go through them really quick. This was region B. Kind of show you that. And you can see them on the blog. I uploaded those really good. Here is region C. I believe that's C. And yep, that was C. And then I wrote this down as region D. I actually think the sketches I did when I was out doing this in November were a lot better than the ones I did here. You can compare and contrast them yourself. There's elements I can see that are really good in both, but you can get into this. A little shorter post than what I did today. Let's go over Eadsy Astronomy really quick. I went over to Sinbad, and you can see here, I haven't published this yet, so I can't click on it and make the images brighter. From Sinbad, I took an image that really shows Simeis 147 in its entirety. It's really faint. You can see that here. I also used a tool, and just using that image kind of pointed out where region A was, where region B was, region C, and region D. I've also put together a Word document where I zoomed in and took images of this and put them into a Word doc. So if you want to have access to that, if it helps you to see, it helps me to be able to see these and to sketch them and to really make sure I was nailing the observation. Make no mistake about this, I do enjoy a good fireworks display, especially in the summer. Even in January, as we're coming up, there'll be good fireworks on New Year's Eve, New Year's Day, right when at midnight when we turn here. We always get that. Where my house is at, I can be in the front yard, I can view the whole Salt Lake Valley, and I can see just about every fireworks show that goes off in the summer. The winter, I'll go out for a few minutes and just take a look, but there's also a lot going on in the neighborhood, it seems. So I do enjoy a good fireworks display, okay? But the universe has its own fireworks display, and we know that's a supernova. Supernova remnants and planetary nebulas are probably my favorite objects to observe. I love to study stars and the life cycle of stars, and these are the end products of a star's life. And the notion, I guess, of a star dying and how it goes and does that even after millions or billions of years is very interesting to me, and how that material is then used to create worlds and other star systems, other stars, planets, and even like us, the iron in our blood originated from a supernova. I think that's pretty awesome. That's how that information goes. So looking at them just kind of reminds me of how I'm connected personally to the universe and to each other. Simeis 147 is in the constellation of Taurus, right on the border of Auriga. It was first identified and cataloged in 1952 by Gregorio, and I'm going to massacre this like I massacre everything, Abramovich Shahan and Vera Verodonova gas at the Crimean Astrophysical Observatory. It was discovered as they saw deep red sensitive photographic plates that showed faint tangled filaments. Originally, they just listed it as Simeis 147 as an emission nebula. At the time, this object was never discovered visually because its surface brightness was so low for classical telescopes at the time. Astronomers reviewed Simeis 147, and the debate began on whether it was a very large H2 region, or an ancient planetary nebula, or a strong diffused emission cloud. It's a huge size. It's over 3 degrees. You can see that in the images, and so it made classifying what it was very hard for astronomers to do. During the 60s and into the early 70s, further studies showed that Simeis 147 had shock-excited gas, not photoionized gas. The object had a strong hydrogen HA emission and a strong O3 ionized oxygen in the O3 range. All this was indicative of what we knew then, and we still know, as a supernova remnant. So by the mid-1970s, Simeis 147 was identified correctly as an evolved supernova remnant that was expanding into the interstellar medium, because that's what supernova remnants do. During further observations, astronomers discovered that there was a hot O-type star, HD 37424, which is very near the geometric center of the nebula. Upon studying that star, it was found that it was moving rapidly through space, and the trajectory of that star was away from the center of the nebula. It was more than likely identified that it was once part of a binary system, and that gave astronomers circumstantial evidence that the nebula was of supernova origin, and that it was felt that this companion star had been shoved out when its companion went supernova, and that's why it was hurtling through space. Had a post on that if you go back and take a look at that. Then in the 2000s, a faint pulsar, PSR J0538 plus 2817, was discovered near the remnant. And according to the pulsar's age, the proper motion and location, it aligns well with Simeis 147's origin and age and everything else, components. And so linking all that information together, and realize, look at this, it took 30, 40 years for them to link all that information together to have enough information to actually say then and draw the conclusion that yes, this is a supernova remnant, and it's undoubtedly a supernova remnant. Its estimated age is between 30,000 and 40,000 years old, and that's very old by supernova remnant. It's the oldest, I believe, supernova remnant local to us. Due to its age, the remnant has slowed substantially, and the shock fronts have become very weak. The emission is extremely faint now and very filamentary. When you combine all that together, that's why it's so hard to see this object visually. On November 20th and 21st, 2025, I spent the evening out at the Knolls observing. I went there myself. I only told my wife I was going. Didn't tell anybody else. Didn't tell Shane. Sorry, Shane. But I knew I was going to be chasing down this object. And when I really go after a faint object like this, and I haven't done it for a while, I really like to do it on my own the first time. Without anybody around me, no distractions, no anything. I can just really focus on what I'm doing, because it takes a lot of intensity to go after these type of really faint objects. For me, it does. So I went out. I got about 10 Herschel objects in. I'll post those later as part of all this other stuff that I got going. And but I want this post to really focus on Simeis 147. I've been here before, like I said, January 17th. Here's the link to that blog that you can go back and take a look at it if you want. And like I said there, and I'll say it again here, I'm going to acknowledge up front that this quest for Simeis 147 was spurred by the post by Rich Jackal and his observation of Simeis 147, and Jim Shields' Bright Regions of Simeis 147 Finder Chart. Still use Rich's and Jim's info. Like I said, it's been 9 years. So I wanted to see if I was still up for the challenge. It was 50 before when I saw it. I'm 60 now. I want to see what 10 years did to my ability to detect this. My goal that night was basically to try and recreate Jim and Rick's experience in observing this faint and ever-growing fainter supernova remnant. And I need to adjust that. Sorry. Saw that. That I was taking that right from the notes that I had from the observations that I did, the sketches I did. So that evening, I never pulled out the Pi Finder. I'd star hopped all night. I still like to star hop. I love the Pi Finder. If you can't tell that, then you don't know me very well. I love the extra time it gives me observing and stuff. But sometimes, especially on faint objects, I just need to star hop. And this was one of those nights. No Pi Finder, all star hopping, even on the Herschels. Here's how I started. I went to Elnath, Beta Tauri, and from Elnath I used the Telrad and moved 3 degrees east toward star SAO 7732, which is also star HD 37098. That took me basically to region A. From that star I began to sweep using the O3 in the 30 millimeter Nagler, and moved and just did it really slow. That helped me to be able to detect faint filaments as they streaked past, and it lays east to west in that area. The O3 really popped it with the 31, and it's long linear streak, and has areas that are slightly brighter than some of the other dimmer parts, and there are others that are just really faint. The entire structure is faint, and this is not for the faint of heart. I put that in there, or a new observer who doesn't have the skill to do this. You need to be experienced at finding details in bright objects and moving to seeing details in faint objects, I think. Having said that, I never want to have somebody say that I said not to give something a try. If you want to go after it, you go after it, and let's hear how you do with it. I'd love to hear that. I'm going to make a chat. People can respond in the chat if they want to this. So anyway, here's the first sketch of region A. You can see how faint it is, and take a look at that, and pretty realistic. I think it was more realistic than I had the first time. You can see here is the actual sketch. I'll just kind of hold it up, and you can see it's on there. So the sketch was raw. I haven't processed these. You can see that in the stars. Sometimes in the winter time the gel ink just doesn't flow, and so I get these stars that are just not really as round as I want, but some of them, as you can see, come out really nice and round. So it just depends how well things are flowing out of the pen. It was cold. It was about 28 degrees when I was observing. It was after midnight. Anyway, north is bottom on that sketch, and you can take a look and see. I mean, I still think it's a little brighter than I actually like to make it, but part of that is just when I use the pastel chalk using the Mellish method, it just kind of sometimes it's hard to judge in the dark of the night. I'm not going to fix it. This is what it is. This is what it looks like. I do think it looks better in person. If you're ever around and want to take a look at my sketches, I'm more than happy to share them. The next one was over to region B. I basically hopped from region A to region B using the chart that I had, and again staying in the 31 millimeter Negla, if I could talk, and using the 2-inch 03. Both kind of vary between the DGM and the Thousand Oaks that I have. Again, just carefully sweeping with the scope, going very slow. Region B, I think, has some of the more interesting filaments to me. They interconnect, and the ones on the end seem to form a square or a box. You can see that in images. You'll be able to see that in the sketch. You definitely need the 03 filter here. You definitely need to use averted vision. Just looking off axis just a little bit will help you to see it. Shaking, I'm not a big fan of shaking scopes to see stuff, but I will say here, shaking it did help to pop some of the filaments a little bit. Again, not a great capture of the sketch, but here is the sketch. It's inverted, upside down. This is what it kind of would look like if you were looking straight on. This is how I saw it, and that's how the sketch is. You can see over here that little box shape, very bright over here, but kind of faint. It kind of fades out as it comes down there. Anyway, talked about that. There were a lot of small arcs, small filaments, a couple knots. You can see a couple knots in the sketch here and here and here. Another one up there, a couple in here. When I say knots, it's not like they're popping out like on some galaxies. You're really going to have to use averted vision to get those in. Now went back to Elnath, and then over to region C for me, because it was easier to make that star hop. And when I got to basically SAO 77354 HD 37367 and SAO 77381 and HD 37557, I was able to begin to examine some of the filaments in there. The region C lays between these two stars. You can see it in the sketch. Here they are. Okay, one's 6 magnitude, one's 7 magnitude, and I thought this came out a little blurry. I think I retook it and entered it, so I think it's a little bit better than the first image that I had taken of this. It's still a little blurry, but I actually kind of like the blur. That's kind of how it was in the eyepiece. The central knot was easy to detect. I could do that with direct aversion. I got it with averted and held it with direct, basically. I had to have excellent transparency to get this, and a lot of averted vision. You're going to need a lot of that in this region C, to get that down. From region C, it was pretty easy to move down to region D. I went to HD 37683 or SAO 77397, and then I just moved slightly over about 30 degrees. it's somewhat dense, and the stars are loosely intertwined, and they're kind of loosely scattered. But there also seems to appear right at the center of that, kind of something that kind of like right here looks like an open cluster, a small open cluster to me. The stars are about 10th magnitude there, a little fainter than that in some areas. And around that group of stars, it was pretty easy to see the nebulosity in here, and to get the wisp and the knots in some of the brighter portions that really just stuck out. Tapping the scope popped it out a little bit more. You can see I got an L there. Let's take that out. And a lot of the knots and brighter parts. North is down in this sketch again. Actually, I mean, I'll be honest, I think that was probably one of my favorite sketches. You can see a little bit, it's a little bit better here than even on there. Got a little fainter on that. That's probably more realistic on the screen of what I saw. That's probably a little too bright. If I had more time, I could probably take the sketches and do a digital rendering here in GIMP and probably get it even closer to what I actually saw with the eyepiece. I may do that if I get time. I may not. It might be a fun exercise. Sometimes I like to do that when I have time. I like to play around with that. What you're seeing here is what I did at the eyepiece. These stars are a little bit better still. Getting used to getting back and making round. I got to practice my round stars. Looks like a little bit more. Anyway, now just as Rich Jekyll did, I made a composite sketch of all my observations. I think it mirrors his too much. I think I have his sketch in my mind, and I think you're going to see that reflected here. And I put a link here to where you can go over to Adventures in Deep Space and see his and compare it to mine. Mine's fainter. It probably requires a little more averted vision to see, but there it is. You can see the box area here, some of the brighter regions. There's A, there's B, there's C up here, and there's D. Anyway, you can decide whether you like his or mine better. I think I kind of like his a little bit better, but it's okay. I'm not. People don't like what I do sketching. That's fine. I do it for me, and I just share because I do really try to make it a little more realistic of what I'm seeing. Not Rich did a great job. He did too, but I really like to try to show what I'm seeing through the telescope. Anyway, what does it take to really see these brighter regions? Let's talk about that and kind of end on that. I did a post on transparency. I did that for a reason because I knew I was going to be talking about faint objects. And transparency on deep sky objects is critical. If you're going to go after something like this, you better have excellent transparency. I'll put some images in before I post this of what the sky looked like at sunset. It was just gorgeous that day. You got to have excellent transparency. If you look up and see a faint Milky Way that night, that means the transparency is probably not so good. It's just going to wash this out. You're not going to see it. You really need to observe this during a moonless time when there's no moon up in the sky. You don't even want high cirrus up there or a lot of dust or anything lower in the atmosphere that's causing light pollution to scatter even farther up. Any of that will dim this out and you won't see it. In November, I did this after 12 o'clock a.m. Observed basically from 12 to about 2:30, 3 o'clock. And right now, going into December, probably 9:10, probably January, February, you could probably do it just a hint earlier. The key is that you want Taurus really up near zenith for it, as high as it's going to get. It's best, it's just the sky's darker there, you're looking through less atmosphere. And it makes it a little bit easier to see it. You got to use an O3 filter on this. If you don't have an O3 filter and you want to go after this, I highly recommend you get a quality O3 filter on this. You can use a UHC filter. It will show less overall. It will provide less contrast than the O3. You'll see parts. You're just not going to see as much as you would with an O3. Don't use an H-beta on this. It really doesn't do anything for it. If all that is good, transparency, time of night, you have a great O3 filter, then whether or not you see this object will come down to the eyepieces you use and the exit pupil. For my 17.5-inch job, the best I think for here, as I calculate it, would be an exit pupil of 5.5 to 6.5. If your pupil is less than 6, yes, you're going to waste that extra light, but you want something in that 5.5 to 6.65 range. For me, with my paracore, it meant the Pentax 30 millimeter. That gives me an exit pupil of 6 with a magnification of 74. The 40 Pentax XW gives me an exit pupil of 6.14 with the paracore, magnification of 71. The Negler 31, which probably was the one I used the most, exit pupil of 6.2 and a magnification of 71 as well. I did use the Negler 26 a few times. It gives me an exit pupil of 5.2, magnification of 85. It brought out a little bit of the tighter knots. I tried the 22 Negler 2 and the 20 XWA. It really dimmed out a lot of the portion parts, but they also did pop some of the knots that were in there, and I kind of talk about that in the post there. Some other tips that I can see based on my notes that I have in observing this is, like I've mentioned it several times, slowly sweep the telescope with the filter in. It will help to kind of just bring the filaments in. Get the bright stars, put them out of the field of view, and then just let the filaments and nebulosity just kind of drift into view, and use averted vision. Use a lot of averted vision on this. If you don't know what that is, instead of looking directly, just look off just a little bit. It helps just to pop some of those filaments and stuff. Let's see what else. Also be willing to take out the filter and see what you can see. I did that a few times, and I actually was surprised I could see more of it than I thought I would. Nice little challenge to see what you can see with and without the filter. So don't be afraid to pop the filter off and just take a look. You can always pop it back on and reacquire the filaments and nebulosity that's there. The filaments, I'm going to be honest with you, they're very ghostly. They're very thin and narrow. You're going to see some knots and some brighter clumps or portions in those filaments. It doesn't look like spaghetti. I said that to begin with. Visually, it's more like a bang of tangled up threads that kind of are interwoven and run together. So if you can think about that. Some possible reasons why you may not see this object if you go after it. First, anything less than excellent transparency is going to kill it. You're not going to see it. Okay, makes it almost impossible to see. If you're using the UHC filter, you're probably going to miss parts of this. Use the O3. Some try to observe it when Taurus is farther down in the sky. Don't do that. You're looking through too much atmosphere that's going to scatter and make it just that much harder to see. Don't do that to yourself. Use the right eyepieces, those in the 5.5 to 6.5 exit pupil range. And yes, I know, like I said, if your pupil is smaller than 6, you're losing some light, but you still want to try to be in that range. Is it worth the try? Absolutely. If you have the right equipment and you really want to test your observing skills, go for this. Think about what you're seeing. You're seeing a star that blew up 30 to 40,000 years ago. Not only did it provide celestial fireworks back there, the faint remnants that there still signifies what happened when that star blew. Think about it this way too. When I see something like this, like I mentioned before, it kind of excites me. It connects me to the universe. The elements that star created that were thrown out into the universe that are now being absorbed will eventually form new nebula, that new stars and new planets will form from, and hopefully even new life in those planets will form from that. A lot of the elements in our bodies, the iron in them, came from a supernova originally, kind of making us link to the stars. Kind of a cool thought. If you're an imager, this is an excellent lunar object. Like I've mentioned, go after it. I would love to see images. You can send them to me. I'd post them on my page here. If you sketch it and see it, I'd love to hear that. I'd post your sketches too. I have one more SNR. I'm going to revisit IC443, waiting for the right night with awesome transparency again. And I'm not tired. I think that's something that I need to mention on this object too. If you're tired, if you're fatigued, and you go out and try to see this, I find that if my eyes are worn out a little bit, things been going on, I haven't slept well, going after a faint object like this really can tire out your eyes and makes it, I think, that much harder to see it. Be well rested when you go out on these. So again, if you have anything to share on this, an image, a sketch, just notes on your own observations and what you see, I'd love to hear about it. I'd love to see it. I'll make a chat for this that you can post in the chat. Your experiences, you can email them to me, whatever you would like. Anyway, I hope you have clear skies. I hope you enjoy those skies. I hope you keep looking up. I hope you find connections up in the universe. Have a great night. We'll talk to you soon. If I can get my mouse to stop.